Welcome to our session. My name is Higgy Park. I'm a specialist SA at AWS. I focus on serverless, and I help a lot of our enterprise customers think about how do we build and deploy serverless applications in a manner that is safe and compliant with organizational requirements.
Hi, everyone. My name is Sam Dingler. I'm a senior distinguished engineer at Capital One, and I help scale serverless adoption across the organization.
So today, we're going to talk a little bit about governance. And again, for the developers in the audience, maybe you're going to think, a little bit of a boring topic. But hopefully, we can help think about how do we navigate kind of this conundrum that we have. And the first question you may be asking, maybe as a developer, is why governance? Like, why do we care about this? And maybe an analogy we can think about is, like, when you're driving a vehicle, driving a car, and again, I assume we're all law-abiding citizens, and we're going to drive at the speed limit. But even if the speed limit is, let's say, 75 miles per hour, when you're thinking about driving at that speed, it's a very fast speed. And you can think, what allows you to drive at such a speed? Or maybe you're going to go 5, 10 miles per hour above the speed limit. And the safety mechanism you have is the fact that you have brakes. You have this guardrail in your brakes to allow you to slow down when appropriate, when you're making a turn. So when we think about governance with respect to any applications that we're deploying, but today we're going to think about it specific to Lambda. So you as developers, you're thinking about, my business is saying, I need to deliver these capabilities, these requirements for our customers. Again, we want to delight our customers. And so you as a developer, you're trying to build as quickly as possible, deliver those capabilities to market as quickly as possible. However, maybe your platform engineering team, maybe your operations team is saying, whoa, hold on. We want to do this in a way that is safe, that is compliant, maybe of regulatory requirements. So we want to kind of balance the two of these. And what Sam and I want to talk about today is maybe we can have both of these. If we think about some mechanisms, some tool chains, maybe even some processes, how can we enable you as a developer or the developers of your organization deliver capabilities quickly, but also do it in a way that is safe? So this is a common pipeline that you will see in a typical organization. So you as a developer or developers in your organization will write code, again, delivering features for your customers. And you're going to do that on your workstation. Eventually, at some point, maybe you've done a bunch of unit tests, integration tests, whatever appropriate testing you're going to do locally. You'll then commit that to your repository, at which point it will trigger some type of pipeline deployment. Right? So you can imagine it'll do some code builds, it'll do some static code analysis, et cetera. Eventually, it will take that artifact, land it in some type of artifact repository, maybe in our case, S3. Then you'll see a deployment process. Again, maybe you're going to do blue-green, or maybe some type of canary deployment. And then you get into production. In our case, we finally got our Lambda function deployed into production. So today, we're going to talk a bunch about what are some safety mechanisms to allow you as an organization to deliver Lambda functions into production in a safe way. So here are some tools or examples that we're going to cover today. We won't do this all at once. We'll take this stepwise. But there are a number of tools along this delivery pipeline that we want to consider. And we'll kind of walk you through examples of how to do that. And we have some recorded demos that will show you some command line tools in order to enable that for your organization. So the first thing you may be asking is, OK, we're talking about guardrails, governance. What does that actually look like? So here are a couple of example controls. Right? And this is, again, going to be specific to AWS Lambda functions. So maybe you're going to say, we want to prevent our functions from being publicly accessible. Right? So I don't want to invoke it from a public endpoint. You may also say it has to operate within the context of my organizational VPC. So it's going to be something that operates within our private network. We also want to prevent it from egressing to the public internet, because maybe I have concerns about data exfiltration or just that response payload making it to the public. Right? So again, there's a bunch of these. One example we're going to use is this third one around runtime deprecation. Right? So there are a number of runtimes that are maybe in the next couple of weeks will be deprecated. And so we want to think about what does that mean for us as an organization, and we'll use that as an example. Another interesting challenge is that these controls evolve over time. And I was trying to think of a good analogy for this one. And again, so I'm a father of 3 kids. I have one middle schooler, 2 elementary schools. And I think about when I'm parenting my kids, maybe when they're an infant, I have certain guardrails or certain rules, maybe around nap times or how you feed them. Then when they're a toddler, maybe there's different rules, like maybe we're going to put up safety gates or things to prevent them from opening the cabinets. Then in adolescence, maybe there's a different set of rules. Again, my oldest is a preteen, and Honestly, I don't know the governance guardrails for that afterwards. But you can imagine these things are evolving over time. The same thing for you as an organization. Maybe you begin with a certain set of controls for your organization, but maybe there is some type of incident or some type of event that happens in your organization, and you realize, you know what, we need to adapt our controls in order to handle that incident that had just happened. So you can imagine over time, these controls will change, or at least evolve. Now, what happens is, as you're evolving those controls, you'll have developer tools that will ingest those policies or those controls. You also have a production environment that is being deployed over time, right? So you can imagine, like an example would be if you're using the AWS CLI, as a developer, you've installed a particular version. And we just had Bedrock go GA not too long ago. There's a ton of announcements you guys are learning about. So there's new features that need to be enabled in those CLI tools. So you as a developer, if you want those features, you have to go and update those CLI tools, right? So that's going to be different versions at the developer level. But also in production, I've been deploying Lambda functions, let's say, over the last year. So I had some functions deployed in January, some in March, some in August, whatever month it might have been. But at certain periods of time, those controls maybe had different variances, right? And so the controls that were in place in January have evolved into the controls that are available to us now in November. So we got to think about how do we manage some of that. Likewise, we want to think about the security of the artifacts that we're deploying. So again, as a developer, I want to make sure that the dependencies that I'm importing into my application are secured. Also, when I commit those to my repository, am I going to do scanning against those? We'll talk a little bit about those mechanisms. Likewise, when I store them in my artifact repository, I want to make sure that those artifacts continue to be secured. If they're insecure, we want to maybe mark them as deprecated or unavailable for deployment. And then likewise, we want to look at how do we secure the functions that are actually deployed into our environments. So the framework we want to use for this then is kind of these two sets of controls that we want to think about. The first is what we're going to call proactive controls. And the simplest way to think about that is I want a set of controls that are applied to my resources before they're deployed into my AWS accounts, right? So maybe at the developer machine or maybe even in my CI/CD pipeline. And then the second set of controls will be detective controls, those that will be applied to the resources that are already in my AWS accounts, right? So again, we're going to think about governance in depth using both of these types of controls, and we'll give you guys some examples of how we do that. So we'll take one use case. So imagine Sam and I, we've got our own organization. We're going to be developing an application. We're going to use Lambda as our compute. And we want to think about how do we evolve as developers or maybe even as platform engineers our controls for ensuring that our applications are being deployed with safety. So our first scenario will be as a developer. Again, maybe I'm a developer. I'm a Python developer. I love Python. So I've deployed a bunch of functions using the Python 3.7 runtime. Sam, on the other hand, he's more of a Java developer. So he likes Java or even maybe the JavaScript type languages. And this is our production environment. So we have a whole bunch of different functions of different runtime types. Now, one thing that we want to be aware of is that, actually, let me go back real quick. One thing that we want to be aware of is we talked about those controls before. And for example, Python 3.7 is a runtime that just went under phase 1 deprecation yesterday, right? And so now as an organization, under phase 1 deprecation, now I can still update my functions, but I won't be able to create new functions, right? And then once we get into phase 2 deprecation, I'll no longer be able to update those functions. So now as an organization, I'm thinking, you know what, I shouldn't be using 3.7. I should probably roll forward. And right now, Python 3.11 is our latest available Python runtime. So now, Higgy as a developer, now I got to think about the first problem I have is I have a large number of functions that are deployed using Python. I got to go and find that inventory of functions in my environment. So we're going to use some detective controls to try to go and inventory all of the Lambda functions I've deployed into production that are using Python 3.7. So here at the bottom right, we're going to look at AWS config as a service. And it actually operates in two different modes. The first mode we'll think about is config and detective mode. Right? So again, another analogy here is thinking about what config does. It's really just monitoring for changes. So in my home, I have a do-it-yourself security system. Right? So I have a bunch of cameras set up in my house. And those cameras are looking for any type of movement or sound in my home. And it's essentially detecting a change from basically quiet or no motion, right? And so it will basically notify me in the event that there is any type of motion or noise. The same thing with config and detective mode. You could essentially enable what's called a recorder. And that recorder will then go and observe based on what you've enabled. So I can say, I'm going to record all actions associated with Lambda, right? So if there's a new function that's created, maybe a function that's deleted, a function that's updated, those actions will then get recorded by config and can then trigger what are called rules. So rules are basically the actions you want to take based on whatever those events might have been. You could also package rules up as what are called conformance packs if you wanted to deploy these at scale. So we'll walk through an example then. What can I then do with some of these findings? So here's the console for AWS config. At the top left, you'll see that there's compliance status against some rules. You'll see there's a bunch of violations against some rules. There's also some resources that you have in there as well. On the bottom left, there are some non-compliant rules, and it'll show you actually the number of non-compliant resources. So maybe those are some you want to investigate. So let's take a quick look at a quick demo through the console. So here I'm going to click on one of my rules. This is the Lambda inside VPC. I can actually then click and look at a particular function, drill down and see, hey, this is the function. And then these are actually all of the rules associated with that. I could then click on a rule within that to say, maybe I want to see other functions associated with that non-compliant rule. And here's one where we're going to have a rule around tagging. And then in the middle right, it shows that annotation. So in this example, it's showing the available tags that are associated with those functions. And in this case, I'm actually expecting 3 particular tags. So this is a simple example where I can use some of the dashboarding and reporting to look at why are my functions actually non-compliant. So now as an organization, I could take remediation action. So this is my reporting to help me identify resources that are non-compliant with organizational policy. There's also a blog post. There's a link at the bottom. Again, these resources will be available afterwards, where you can actually take config data, and you can actually export that into S3. And then you can imagine you can use tools like Athena, and you can use QuickSight, and start to create dashboards around some of these resources. Here's an example where we look at a distribution of how layers are applied to my functions. Maybe you actually have a layer that has a vulnerable dependency, and you want to identify how many of my functions are using that vulnerable dependency. So that's a quick overview. I'm going to actually turn it over to my colleague here.
Great. So one technology you can think about using to express your policies is something called Open Policy Agent, or OPA. This is open source technology, and it's a declarative way of describing what you think are non-compliant configurations of your resources, right? So it doesn't require coding, it's just syntax, and you can describe the configurations that are out of compliance with your standards. So here we have an example. This is an example that we're looking for Lambda functions that are not attached to a VPC. So Higgy mentioned one of the controls we might want to enforce is that we want all our Lambda functions to be attached to a VPC to keep network traffic within our VPC. So in this example, the DSL, the OPA DSL, is allowing us to identify the configuration and the value in a comparison to that value to identify that if the VPC configuration ID is empty, that means we don't have it configured to VPC. This is a non-compliant resource, and we want to take some type of action as a result. So OPA also allows you to take action and describe different types of actions. So you can notify, right, that something is out of compliance and someone needs to take a look at it and correct it. You can also take corrective actions as well, and you can use those in combination together. So this is an example for how we could do that. Now, when we think about how we might deploy something like OPA policies as detective controls, as Higgy was mentioning, into our environment, there's really 2 portions of this. There's a control plane, like how do we go about managing what these policies are? How do we have a pipeline? How can we make changes to those in controlled ways, just like we would with the changes we make to our applications and deploy those in our environments? So you can see across the top, we have a developer workstation. This is where a security engineer who's responsible for creating these OPA policies, for example, will commit these policies to code repositories, just like you would with your application code. These go through a pipeline and are deployed into an environment specific for managing these policies. There's lots of different technology you can use for how you might host these policies and use them. In this example, we were showing an S3 bucket being the destination, the deployment destination for those policies. Below that, we'll see an AWS environment. So here, we can see there's 2 ways that we might want to evaluate those policies. One is, as Higgy was mentioning, right, we have a security system. We want to react to events. When are things changing in our environment? So we can have an event-driven mechanism that can trigger a Lambda function, and we can react in near real time to the things that are changing in our environment. Or we could have a scheduled mechanism as well. So periodically, we can have something that triggers, say, like an AWS batch or a Fargate task or either another Lambda function. The key here is that both of these mechanisms can reference the set of policies and then use them to apply it to your resource configurations to determine what is out of compliance and where you need to take action. One advantage of using something like S3 as a storage for those repositories is that it's a great scaling mechanism. So as the number of policies grow, as the number of environments grow, you don't need to worry about stacking more demand on top of a data source, right, that might not be able to scale horizontally with that. So S3 is really simple to kind of build on top of it, and it can scale with your usage of policies and your environments as well. So here's an example notification. So here we have an email notification, right, that we have an out-of-compliant resource. Now this one isn't a VPC configuration. This is that our function is missing tags, right? So you might have heard from Higgy or other AWS essays that having a tagging strategy in your AWS environments is really important in order to do things like cost allocation and security and identification of your resources. So when we look at this notification, there's a couple of key pieces of data, right, that might seem obvious but really critical to your developers that are going to be receiving these notifications and have to be able to react to these. So the first is the account, right, that this non-compliant resource exists, the region it exists, and then a very easy to understand description of the control that was violated so that they understand what is the problem so they can go fix it. Now one detail here, we have a control ID, control123.v1. I think often this is overlooked as a really important part of as you mature your policies in an organization over time. So it's really important that you have like a sense of lineage. You don't want the controls to be arbitrary or not based on documentation that people can't follow up on to understand more deeply what is the source of the standard driving this control, what are the details on how this control evaluates a resource so that they can understand the symptoms of what they're observing and being notified for. So that is kind of a non-functional important thing as you're building your set of policies in your organization and maturing over time, is that you start from a really solid foundation, control IDs, descriptions, and links to references where people can go learn more information. So you can see at the bottom, we have a remediation action. This tells the engineer very in plain language, right, what they need to do to correct the action, and if that's not enough information, maybe this is the first time they've seen this, then we have links to docs or Slack channels where you can get more information, right? So you have to know that your engineers in a large organization, there's going to be a lot of these controls that appear over time and change over time, so you really need to go out of your way to help them with plain language and easy to follow instructions on how they can stay compliant. Okay, great. So in our example, right, we had a Lambda function, right, that is now non-compliant. So now we have a detective control. So the next time that Higgy deploys a Python 3.7 function, we will know based on an event that is triggered that this has happened. We can notify Higgy, let him know that he's done something bad and needs to correct his action. So now we're in a better state than we were before. We can catch new things that happen, but we can't necessarily prevent Higgy from making a mistake accidentally. So that is where we'll go next.
Cool. So yeah, maybe I'm a forgetful engineer or a forgetful developer. So I was notified at one point that maybe I shouldn't be doing Python 3.7 functions, but you know what? I forgot. Maybe I'm cloning from a repo that this is the set of templates that I'm using, and in there I've got a configuration parameter that's saying we're going to go ahead and keep using Python 3.7. So we want to kind of prevent me from being a bad developer, a bad corporate citizen. How do I do this, right? And so we want to prevent drift. So we've actually remediated all of the Python 3.7 functions that have already been deployed to my account. Now we want to prevent additional 3.7 functions from being deployed. So one way we can do this is a service called, or a capability called AWS CloudFormation Guard, right? So what we're going to do here is template validation. A simple idea here is you can take the CloudFormation Guard tool. So this is just a CLI binary that you're going to put on your local developer machine or even have in your CI/CD pipelines. And there's basically two inputs. One is just a JSON or YAML formatted document. In this case, it could be a CloudFormation template, but it could be other documents as well. And then a set of CloudFormation Guard rules, right? And so we're going to talk about how these rules are applied, but it's essentially a DSL to define some of these policies that we care about. And then at the end of that, you'll basically run this CLI tool, and you'll have a pass, fail, or a skip in the event that we didn't care about that particular resource or it was out of scope. So here's an example of what that CloudFormation Guard rule looks like. So there's a couple of components. The first one is the resource type, right? So if I'm going to be looking at an EC2 volume as an example, it'll be of volume, AWS : EC2 : volume. Now, one thing that we want to do is we want to check, is my volume encrypted? Because we want to ensure that all of our EC2 volumes in our organization that are deployed are indeed encrypted, right? So you can basically take the property, and then you have this operator and expression. And basically, if it evaluates as non-compliant, it will then spit out this custom message that I've specified here, where I'm basically saying, in this case, EBS volumes must be less than 100 gigabytes because we're trying to cost optimize on our volume usage. So if we take an example look, again, Higgy, the developer, I'm a little bit forgetful, or maybe I'm being intentionally, I just really want to use my Python 3.7, and so I'm just going to keep trying to jam it in. So now the organization is saying, we're going to try to stop Higgy from being a terrible corporate citizen, and we're going to actually enforce a preventative control. We're going to prevent Higgy from doing some bad things in our environments. So there are actually two things to think about here. We're thinking about runtimes that are already deprecated. So these are so Python 3.6 would be an example of already deprecated, and as of yesterday, Python 3.7 is now in phase 1 deprecation, right? So we have a rule here called Lambda already deprecated runtime, and there's a couple of components. So there in orange, you'll see that we've actually created what's called a query. It's going to look for all Lambda functions in my template. And then again, in this case, we're going to look at the runtime value or the runtime property of my template. We're going to for compliance purposes, we're going to say it has to not belong to this array of values. And then if it's non-compliant, it will then spit out this particular this error message. So here's an example. I'm writing a CloudFormation template. I'm specifying an AWS Lambda function. And again, Higgy is a kind of a non-compliant developer. I'm kind of forcing my way in. And I've written a template that includes a Python 3.7 runtime. The bottom there is what the CLI command would be. So now on my local workstation, if I've installed the CFN guard binary, I could run this command against that guard rule and against my template. And I can then see that my template actually violates compliance. And it's going to end up failing a CI/CD deployment. So here's just an example of me doing a template validation. So I've written a bunch of code. I've written maybe some of my unit tests, and they all pass. I'm ready to commit it. But before I commit it, I just want to make sure my template is good. So if I go ahead and hit play. So here's just an example of a rule file. Again, this is similar to what I showed in a previous slide. Here's an example of a function that I've just defined. And in this example, it's a node 12. So this is already deprecated. And here's an example of me running that CLI tool. Here's that full output. And it's basically describing the fact that I've been non-compliant for that runtime purpose. Here's an example of ensuring that it's VPC enabled. So it's basically looking to ensure that that VPC config property is part of my definition. And again, here's a list of a bunch of those where that VPC config property is missing from my template. So those would then evaluate as non-compliant. And here's one for soon to be deprecated. Again, this was recorded before 3.7 went deprecated. Here you'll see that I have that 3.7 runtime. Again, I would expect this to be reported as non-compliant. And here at the top, you'll see it says that it was a failure. So this is a tool that as a developer I can run. And part of why this is important is as a developer, I don't have to wait for that pipeline to deploy and then fail. Maybe that's a couple minutes later. And so this helps me just get better feedback much quicker. Another mechanism that we can use, so this is maybe in the developer side, like on the local workstation. We could also deploy that in our code repository as a webhook. It could even be in our deployment time as well. We can also use AWS config, before we talked about it in detective mode, for kind of discovering resources that are non-compliant against our rules. We can also use it now in proactive mode to prevent resources from being deployed. So the way that we do this is, again, like Sam was saying before, maybe you have now a platform engineering team that's working through these policies that they want to enforce against resource deployments. They're going to deploy those as a conformance pack, as I had mentioned before. Here's some of the examples that we have been using before. Now, here's what that deployment will look like. As a developer, I'm going to write my infrastructure as code template. I'll commit that to a repository. That triggers a CI/CD pipeline deployment, which ultimately does a CloudFormation deploy. Now, what will happen is we're going to configure a CloudFormation pre-create hook. So before the resources are created, it triggers this hook, which in this case will then execute a Lambda function. The Lambda function now checks against that config rule and will ultimately return a compliant or non-compliant response. If it's compliant, it will allow CloudFormation to proceed with that resource deployment. If it's non-compliant, it will then basically fail the CloudFormation deployment. So here's just another example. In this case, I'm saying I want X-ray to be enabled, so we want to enable tracing configurations. And setting it to pass-through basically disables X-ray tracing and would then return as non-compliant. Here's an example in the CloudFormation logs. So when I'm doing a CloudFormation deployment, here's just an example of what it would look like if my resource deployment was failed as a result of a config proactive check. OK, Sam.
Great. So at the top here, you can see the OPA policy management, right? This is our workflow for how we introduce changes to policies into our environment. Below is your developer experience, right? So you have your developer's workstation, your repository, your pipeline, and then deployment of those things. So we want to have proactive controls in both places, both from the developer workstation and from the pipeline. Pipeline is really critical, right? It is sort of the way we have trust in the quality of code that we're deploying into our environments. And it's a great place for us to put numerous types of security checks and policy checks so that we have confidence in what's going into our environment in a scalable way. However, as Higgy was mentioning, we also want to give developers the ability to pre-validate that the configurations they're creating is going to be deployable when it goes through the pipeline. So it's really critical that you have proactive capabilities in both places. And as Higgy was mentioning with something like CFN Guard, for example, these are tools that you can run on your workstation, or they can be incorporated into the pipeline as well. So you can not only use the same policies, but in some cases the same tooling as well. It's just being executed in two different kind of phases of the deployment lifecycle. So here is an example of what another type of scanning tool could do. So here we have a tool from the developer's workstation that can scan your local CloudFormation templates, whether they're created using SAM or CloudFormation or synthesized using CDK. And here we can actually wrap in multiple types of validation. So as Higgy was mentioning, these types of tools could include other AWS native tools like CFN lint. So you're able to quickly catch any sort of syntax errors, right, before you kind of go to the more expensive tests against policies. However, we can also layer in sort of our own custom policies that we want to enforce as well. Now here, kind of like in the notification, it's important that you carry through these standard messaging and control IDs so that you have consistent experiences, whether it's in notifications or developer tooling. You'll also want to ensure that information that's conveyed in pipeline logs also is consistent with what you're seeing. So the idea is that if the developer is able to validate the configurations locally, unless there's some sort of change, to the policies or the configurations outside, as a race condition before they deploy it, then they should have confidence in that the pipeline is going to also agree with their local experience. And that's really critical for that developer feedback loop, right? So we want to enforce policies in the pipeline, but depending on your pipeline configuration and your build and test phases, it could be in the order of minutes until your developer gets feedback that they have a syntax error or non-compliant resource configurations. And if that happens again and again and again, especially when you're building serverless architectures, which has a lot of infrastructure as code configuration, then that's not the best developer experience, right? Developers are waiting a lot in order to get feedback that they have the correct configurations. If we can take the same policies, enforce them with the same tooling, but do it from the developer's workstation, you get that nice feedback loop locally, but you get consistent experiences when things are deployed through pipelines. So you kind of get the best of both worlds. So now we've enforced, so he's not able to go around, he's not able to deploy Python 3.7 now. We've blocked him on the proactive controls as well. So you can see in our environment, we've identified all the 3.7 functions, we've remediated those have been upgraded to 3.11. And now at this point, Higgy's not able to deploy new Python 3.7. So what's the next step?
All right, I'll be a good guy. I'll be a good boy now. So now we're thinking, all right, I'm compliant. I'm going to develop my functions using Python 3.7 or 3.11. Sorry, see, it's the bad side keeps creeping in. So now we're thinking, how do we continue to even evolve? How do we continue to get better, right? So now I'm using Python 3.11 locally. I'm going to deploy those into my environment. Some other things that we may want to think about as an organization is we want to ensure that that the artifacts that I'm now committing and deploying are actually the ones that I've written, right? So one thing that if we take a quick aside, we have this concept called code signing. And it's basically two main concepts. One is we want to ensure that the code that I've written is unaltered by the time it gets deployed into production, and also that it's coming from a place that I trust, right? So it's a proof source. So Higgy, as a developer, has committed a code repository, but ultimately it's actually the tool chain, that CI/CD pipeline that will be doing that deployment. And we want to make sure only our CI/CD pipelines are doing those deployments. So we want to ensure that the code is unchanged and it's coming from somewhere that's approved or trusted. So one way we can do this with Lambda is basically these two components. And we're going to talk about a little bit more detail how they actually work. But you start with what's called a signer signing profile. You can imagine I'm going to be using like cryptography keys. This is the thing that's going to be signing the artifacts before they're deployed. And then with Lambda, you have to configure what's called a signing configuration. We want to associate that signing profile to my function so that every time I do a deployment, we're going to use this signing profile to verify the signature of that artifact. So how does that work? So this is going to be that phase. So we're going to use signer to sign during our code build and the artifact build process. And then during the deployment, we're going to use it to then verify that. So let's talk about how that actually works. So when I'm during my CI process, when I'm creating my artifacts, after I've done all of my testing, I've created, let's say, my zip file. I put that into S3, and I'm ready to now kind of put my stamp on it. So we're going to use the signing profile to create a signing job. Right? That signing job will go and it'll essentially hash it and create an encrypted hash of my zip artifact. And now I can have a reference to that signed zip artifact. So at that point, my CI process is completed, and it's going to sit in my artifact repository, in this case in S3. Now when I'm ready to do a deployment, we're going to, again, use that same signing configuration to now verify the signature on deployment. Right? So when I specify my zip file, it should be that signed zip file. And Lambda will then go and use the signing configuration, the signing profile, to ensure that it's a verifiable signature. If it is, it will go ahead and deploy the function. If not, we'll get an error. So here we'll see a quick demo of how that whole process works. So here I'm going to actually just show my signing profile configuration. Here you'll see I have my platform ID set for Lambda. I'm going to look at a quick event payload. So I'm going to actually trigger my function, again, just key value. So we're going to invoke it. And that message on the bottom, that hello world, just think of that as my business logic. Right? That's the thing that's going to be changing. So here as a developer, I'm going to go and update. Again, I'm a Python developer. I'm going to update my business logic from hello world to hello reinvent. I'm going to now go ahead and package. So this is my CI process. I'm packaging, creating that zip file. And I'm also doing it with a signing configuration. Right? So here's that signing job that we just went over. And we're going to actually go ahead and look at that signing job once this continues. All right, so let's take a look at that signing job. And here's the output of that signing configuration. And what you'll see is at the bottom of that output is the signed artifact that we're going to then use for the deployment. So here we'll go ahead and do a deployment. Again, I know that there's a lot in there, but basically you'll see that there's a signing configuration we're passing in as a parameter. We've passed in our signed artifact. So we would expect that this deployment would complete successfully. This will take a couple of seconds, but in this case, the deployment will complete. And what we'll then do is we'll then go ahead and execute our function that we've just updated. We would expect now our business logic to be updated to now go from hello world to hopefully hello reinvent, assuming that this deployment completes successfully. All right, so it looks like our deployment is completed successfully. We're going to go ahead and do another invoke just to make sure that our functionality is as expected. OK, hello reInvent, so we're good. Now, the thing that we want to think about is, all right, let's look at the alternative where maybe I'm a developer and I'm not going to go the correct route. So now we're going to actually have an unauthorized change that's not going through this signing process. So this is unauthorized. Here you'll see I'm going to actually go through a CI process, but I'm actually not going to sign it. Right? So there's actually no signing profile at the end of this. We're just specifying our S3 bucket. We're not actually using that signing profile. I'm going to try to do a deployment here. Again, my expectation would be, because now I'm using an artifact that is not signed by AWS Signer, I would expect that this deployment should be blocked. So Lambda will now use that code signing configuration. We'll look and say, hey, this artifact that you're giving me doesn't match the signature that I'm expecting. So it's starting and it's evaluating, looking at that artifact, and I would expect it to get blocked. Right? So here you'll see it says Lambda cannot deploy the function or layer because it's not using a signature that we're willing to accept here. So this is good. So now we know that the artifacts that we're deploying for our Lambda functions, we can verify that it's unchanged from when our CI process has created the artifact, but also we can verify it's coming from a place that we trust. OK, so now we know that our artifacts are good going into deployment. Now we also want to check from a runtime standpoint, are those artifacts still secured? Right? So we can actually use Amazon Inspector. Right? So this is more about runtime scanning of our code that it's deployed into production. So one thing that happens is Inspector will actually look at the Lambda functions deployed into your account and will automatically detect for maybe insecure packages or even insecure code. So the way that it does is with this continual scanning, again, like Sam was saying before, this notion of event-driven scanning, the way that this works is if you create or update a new function, again, that would be a scenario where Inspector would go and inspect that function. Another example might be, let's suppose there's a new zero-day vulnerability. So there's a common vulnerability or exposure or a CVE that was just published. That will then get published into the Inspector database. And we will then go and trigger a scan against all of the functions in your environment because we want to ensure that you're not exposed to this vulnerability. So there's that managed vulnerability database. And then you can then trigger events off of that. So if there is indeed a vulnerability in your environment, you could either use the Inspector dashboard, or you can actually use some type of event triggers in order to do that. Now, when we're scanning our functions, there's two ways that we can think about scanning our functions. I'll show you an example of this momentarily. But there's standard scanning, which is our default. And what this is looking at is the application dependencies. Right? So if you're using a dependency that has some known vulnerability, standard scanning will go ahead and detect that. There's also code scanning. Right? So this is actually the code that your developers, or maybe you as a developer, have written, and you want to ensure that that code is secure. So here's an example, again, in Python. Up top, I have import boto3 and import in request. These are the dependencies that my application are using. Let's suppose in this example, I'm using a particular version of the request library. There is an open CVE for the version that's listed here. That would be an example where the default scanning would detect a vulnerability in my particular function. Now, let's suppose, again, Higgy's being a not-so-great developer right now, and I'm going to create a boto3 session. And for some reason, I wasn't just thinking, or maybe I was just upcoding really late at night, and I hard-coded my credentials. You as developers in this audience, you would never do that, but I'm just a terrible developer, or I was just really tired. I hard-coded my access key and my secret access key. This is something that the code scanning aspect of Inspector would then detect and would flag for you as an organization. Now, you may also be thinking, again, at certain organizations, you may have a large number of kind of infrastructure automation functions. Maybe as a security organization, you've already hardened those. Now, again, there is a cost associated with Inspector. So maybe for those functions that you've hardened that you're deploying across all of your accounts, maybe you want to exclude those from inspection. So if you apply these tags, you can actually have Inspector say, all right, we see these tags. We'll exclude those functions from being inspected. So here's a dashboard of what Inspector would look like. So again, you'll see that Inspector actually covers a variety of different compute instances. We're going to look at functions in particular. In the top left, you'll see environment coverage, and you'll see, you know what, I have 40 Lambda functions, but it seems like only 45% of them are actually being covered, and you may be asking yourself, why is that? So why don't we take a quick look? So we'll click into that. And we're going to click on the not scanning. And you can actually see the reason there. So here's one that says unsupported runtime. So that's because that's a function that has a deprecated runtime. Here's one with scan eligibility is expired. So the nice thing here is if the function hasn't changed or been executed for 90 days, we'll actually exclude that because nothing has changed, so there's no reason actually for that to be inspected. We can also go down and see a number of functions. So here's one where I was playing with Bedrock. Everyone's talking about Gen AI these days. And here you'll see I'm using a LangChain as part of my function, and it's slightly outdated. There's actually a CV associated with that particular version of LangChain. Here you can actually click on the CV information if you wanted that detail. And then you can actually go back and see more information about the function, the layers associated with it. And here you'll actually see there's a LangChain layer that I've attached to my function. That's probably where that LangChain dependency is located. That's probably the place where I need to go and actually make some updates to the dependency and therefore attach a new layer. OK.
So another technique you can consider is something called a centralized artifact repository. And this has a couple of key capabilities that can help you centralize the same type of scanning that Higgy was talking about. So in this case, we have a centralized artifact repository. And notice that all aspects of our deployment pipeline reference the artifact repository. So that means developers from their workstation, when they're using dependencies, whether they're Python or Java or JavaScript dependencies, those are coming from your artifact repository that your organization manages. Now that artifact repository can pull and mirror public repositories, right? So the major artifact repositories for different languages can pull through. But those artifacts, those libraries and dependencies that end up in that repository can then be scanned by your central's tooling in order to also identify any vulnerabilities. So developers are pulling artifacts and using those, using all the same type of tooling, right, except with configurations that reference the central artifact repository. And then so not just public artifacts, right, but any artifacts that are produced by internal to your organization also go into this artifact repository. So you might have some teams that are building libraries, right, that other teams will use in their application code. Those would be also added to the artifact repository and follow the same type of scanning rules and things like that. So this can be a place that you can centralize, kind of like we're talking about the pipeline. We find different mechanisms and places to engage those mechanisms, right? So we have scalable behaviors and really take that load off of developers so we can have trust in some of these centralized mechanisms. The central artifact repository can be another sort of a way that you can achieve that. OK, so here we have now sort of take the next step. So we have our detective controls, our proactive controls, and now we have the signing capabilities. So we're confident about not only that the code that we're deploying into our environments is code that we wrote, but also that we don't have any dependencies, right, that have any CVEs that have accidentally made it into our environments.
All right, so we're feeling a little bit better that we're preventing bad changes from happening. We're detecting maybe vulnerabilities within our actual production environment. Now we want to think about what are some additional things that we can do as an organization from a process and a people standpoint that can actually help improve the governance of our environments. So we've already covered some of those capabilities. These are just, again, some kind of thoughts that we'll leave with you. When we're addressing compliance findings, one of the things that Sam was talking about is that tagging strategy, right? So you may have a tagging strategy that says, here's an application ID, here's an owner ID, maybe here's an owner distribution list or email contact. It makes it very easy for an organization if you're looking through the AWS console, you're looking at resources that maybe need to be remediated, you can look at the tags and very quickly identify who does this resource belong to. This then goes to that owner outreach, where you could maybe start to generate reports. Hey, we know a particular Lambda runtime is coming up on deprecation by the end of the year. Instead of waiting until like 2 days before that happens, we're going to create a campaign 6 months in advance. Hey, this is coming up. Why don't you as a team start thinking about what's your strategy for rolling forward a runtime or whatever that finding might be? And then, of course, you can imagine thinking about maybe maintaining a configuration management database where you include a lot of this metadata. So it could be things like information about the application, the owner. You could also store things like, here are the dependency versions we're using. So while you could use config to do that, maybe you can actually have simplified queries to say, hey, we know this particular version of requests has a vulnerability against it, or maybe we're using LangChain and something in LangChain is vulnerable. So this helps you as an organization quickly identify some of those things that need to be addressed. Now, another thing too is, again, as a people standpoint, again, me, Higgy, as a developer, I kept wanting to stay on Python 3.7, and I was a little bit reluctant to move forward. And so this is kind of that feedback loop, right? So maybe Sam is going to come to me, and he's going to hold a once-a-month session that talks about, hey, these are some of the best practices of an organization. We know some of you are really grasping on 3.7 for some reason. Hey, we got to move forward because as an organization, this helps keep our application secure. Likewise on documentation, so you could have things like developer portals. Maybe some of you have like Confluence pages or wiki pages where you can start to document some of these best practices that helps your developers be aware of the organizational things. So maybe as a developer, maybe I didn't know that 3.7 wasn't something that our organization wanted to support anymore. I just happened to see it in this proactive control that was being there. And then likewise on training and awareness, we can do things like hold monthly training sessions. We could talk about AWS updates. We could do like an update for all of the things that we learned at reInvent. But we can also talk about, hey, these are the ways that we're actually applying those updates from reInvent for our organization in a manner that is compliant with policy.
So in this example, we've talked about like a specific point in time, Python 3.7, this thing happened and we need to react to it, right? But we know that these things aren't point in time activities. They are ongoing activities in your organization that happen over time. So one thing to think about is how do the changes in your policy in your organization impact existing resources? We don't want to deploy a policy into your organization that will all of a sudden take heavy actions, right, and auto-remediate and change configurations at scale that could cause problems in your organization. So there are ways that you can deploy and then target different accounts and environments, so that you can target and test remediations in your environments and kind of do a one-few-many deployment to kind of trust the impact of those policy changes. Another thing we can do is that we can have a scheduled mechanism that can look at our configurations across all our AWS accounts, and then we can react to those and take an inventory of what are our out-of-compliance resources after our changes to policies. And then we can notify. So we talked about notification actions before, right? Email and Slack. But another thing is we want to treat these types of activities, we want to kind of incorporate those into our standard mechanisms for deploying changes to our applications as well. So often another type of outcome of these types of changes is integrations with issue management systems, right? So you might be using Jira or GitHub Issues or something like that to track your changes, right? So it's really critical that you eventually evolve to a point where you're doing agile remediation, which means that you have a backlog of feature requests along with these types of remediation activities. Now, the remediations may have different priorities. Some might be urgent, right, where they have to be addressed immediately. But oftentimes, many you have some time that you can use to address those. So if we give Higgy 2 months notice that Python 3.7 is going to be out of deprecation, that can be added to a team's backlog, and they can choose when they want to prioritize that work and balance it with the other feature they want to do with their business partners. So you can take this kind of new angle of work and sort of hygiene that needs to happen in your environments, but it can feed into existing control mechanisms that you're already using with your engineering teams to deliver value for your customers.
Cool. So kind of to wrap up, again, we talked about how do we do governance in depth, right? So there's a number of different services and capabilities. This is kind of our software delivery lifecycle that your organization, your developers, or maybe you as a developer are going through when trying to deploy your applications to production. Again, we covered a lot of different ways that we can think about this. So again, we're thinking about proactive controls to prevent non-compliant resources from being deployed into your environments. And then there's also those detective controls to then detect for maybe an evolution of our controls over time, and maybe there are resources that are non-compliant over time. There are a number of additional resources. So throughout the slides, there were a number of links that we had shared to resources that you can kind of follow up with afterwards. So we did create a resource guide. You can find that in the first one. We also did record we have serverless office hours, and that was recorded on YouTube, where we actually demoed some more of these capabilities, where we went into some more depth. So feel free to watch that and look at that. And of course, last but not least, these are a number of sessions that you can go and follow up and take a look at. These are kind of how you can think about building your applications in a secure and compliant way. And with that, Sam and I wanted to say thank you very much. And again, as you've been hearing with all of these sessions, we very much would appreciate filling out that survey, giving us feedback, how can we improve or maybe things that we might have done well. So with that, thank you very much for your time. We do have like 10 minutes, so we can kind of come off stage, and if people have questions you want to ask about some of the things that we've done, we're happy to have that discussion as well. Thank you very much.